do, places to go and all that stuff. Right, we need to be able to see here and here's. So up that up. You also need to be able to see that it's freezing cold. The heaters, we've got heaters, although we won't need those right now because we're going to do some heating. Actually, it's not even plugged in. Right, guys, welcome back to Ross & Co. Welcome back to London, another live jewellery making session. I think in yesterday's live stream, was it yesterday? I lose track. The goggles are still here, the melting goggles. Yesterday, I think we melted some gold, made a gold ingot. Was that yesterday? I think it was, yeah, yesterday morning. I made this gold ingot, which was then, poured it yesterday. I also then made these 3 silver ingots, which I didn't do as part of the live stream. I just made this gold one. Poured it, pinned it, about 3 or 4 times I pinned these. So smacking loads of light hammer blows on a steel block, that steel block there, with a crossing hammer. Reduced them in size. It does something to the surface of the metal, hoping reducing cracking. This is a work in progress, this process. Yeah, we poured that gold one. I know it doesn't look gold because I've been annealing it, but that is gold under the blackness. These 3 are silver. That is about 10, 11 grams of gold, 9 carat yellow gold. So that's what we're working on today. Now, you would think that jewellery making, people have been doing, there's documented history of people doing what we're doing, dating back hundreds of years. I mean, I've got books here from like the ones in my hallmarking video. The books are from like 1815, were printed 1815, but the information there dates back to like 1335 or something, like years. People dig this stuff up in archaeological digs. Like, it dates back thousands of years. It should be, and admittedly, there's a sort of, jewellery making is part art, part science, you know, part alchemy. There is some areas which are art, but some areas are science. And this annealing, the metallurgy part of it, is a science, and it should be a done deal by now. We should be able to just go online and read how to do it, or get a book on jewellery making and read how to do it, and you can't. You go online and it's just people arguing, and I think part of that is like all aspects of the internet where the people that know what they're doing are doing it quietly by themselves somewhere, and the people that don't know what they're doing are shouting about how to do it wrongly on the internet. It's just a minefield, and they're just people arguing. So I was getting quite good results when it came to melting gold and silver, the different alloys. Melting gold, turning them into ingots, and then turning them into jewellery. The way I was taught to make jewellery was, from an annealing aspect, you got things hot. It was a 2-part process, effectively. You got things really red hot and then cooled them rapidly by putting them in water, and that kind of, like, when you're soldering, that works, generally speaking. In hindsight, I've had some issues. So I was making jewellery with antique coins, 3p pieces. I've got one here, and occasionally, have I got one here? I think I had one here. Here it is. Occasionally, is this the one? This is a dud because it blistered. They would blister up, and I could never figure out what it was. And now I know what it is. There's like these minute blisters on the surface. Boom. You might not be, there's like this blistering around the top. You can't really make it, it looks like part of the thing. But the silver would blister up, and I never figured out what it was. And it turns out that if you quench sterling silver in liquid when you're making ingots and then roll it out, it sort of blisters. You get subsurface, the liquid ends up in porosity, below the surface. It then, when you subsequently heat it up, blisters and cracks. So I was annealing silver because until I had a problem, and then it turns out you're not supposed to anneal sterling silver. And this again, I think, is where a lot of the problems end up online, because there's a lot of nuance to things. So yeah, you can, if you're soldering it, the problems you create from annealing soldering jobs don't really manifest themselves in cracking the process because you're not working. The other thing is, I think a lot of people try and apply, so there'll be people that know how to heat treat, or maybe learned 30 years ago at university how to heat treat steel, and they assume that all steels and all other metals, you know, ferrous or non-ferrous, are heat treated in the same way, and they're not. Every different alloy, it seems, has a different, or can have a slightly different heat treatment process. So gold seems to be fine, like pure metals. I think pure silver doesn't seem to make, from what I've read, you can quench pure silver and it won't make any difference. You can quench pure copper, won't make any difference. You combine silver and copper into sterling silver, which is 92.5% minimum fine silver, then the rest 7.5% or so copper. When you combine the two, then quenching then becomes a problem, because it's a different alloy, and so yeah, I think people are applying possibly the results they may have had of fine silver or fine copper, presuming that the combination of the two is the same. And if you give them, but that's just giving people benefit of the doubt. But then also, you know, then people might assume that gold and silver are the same. But again, like there's different alloys. 9 carats, 37.5%. 18 carats, 75%. There's a vast difference in realistically what metals they are. They're almost, one is, you know, let's just say the rest is silver and copper. One's more silver and copper than it is gold, you know, almost, and vice versa. So anyway, gold, we never had. I was air cooling everything, mainly out of, I don't want to say laziness, let's say convenience, because I didn't have anything to anneal it in. Sometimes the wire would get too long and I couldn't, like my little pot of water was big enough, so I just let it air cool, no problems. Then I started having problems with 18 carat, so I figured the proper way to do it was to anneal it. So I started annealing it and it worked. Peening it as well. I think peening, a lot of people dismiss peening. That really helped. The peening process helped. Quenching 18 carat helps. I started doing it to everything, including the silver, but then we encountered a load of problems with the silver because, yeah, again, I applied what everyone else is doing, which is one rule to every alloy, and it didn't work. So my silver was blistering, cracking. If you quench sterling silver ingots, when you roll them out, they basically wring out like a sponge. You end up with water coming out of them. There's enough heat, the water doesn't come out when you heat it. What happens is it expands, blisters the metal, and then again, more problems. Your rolling mills will end up getting tarnished and rusty because you've got either water or worse, pickle coming out, getting squeezed out when the subsurface pores do eventually surface, the water's released. And yeah, problems. So I've come up with a new little experiment, and this is by no means a done deal because, again, it's just something I'm playing around with, but I thought I'd share it with you. So using steel blocks as a heat sink is nothing new, but applying it to ingots is. So I'll quite often, an example of this is, and I know other jewelers do this as well, most of us have got steel bench blocks or blocks. This is a engineer's vice that I use as a chenier clamp basically, for cutting wire. So what a lot of us will do, if we need to cool some metal down quite rapidly, and an example of that is, say I'm soldering a ring together, I haven't annealed the wire, out of, again, convenience, or I've just work hardened it so much from the forming process that during the soldering process, the heat anneals it, the joint moves out of line, you've got to realign it, it's too hot to pick up. Popping that back on a steel plate cools it enough to handle it, and you can realign the joint and start again. That's an example of that. What I've not seen anyone do, and this is where our new title of dry quenching comes in, and don't worry, I've checked it in the Urban Dictionary, it's not some weird practice that the LGBTQ community have, you know, come up with a harmless sounding name for something that's eye-watering they do in the bedroom. But there's time for them to invent something. So yeah, it's something there is something to do with like coal or something, but not in this context of annealing ingots. The silver really needs to be air cooled, I think, from experience and from reading online. The gold, I think, benefits from quenching, by the SPY accounts, but again, there's disagreement about everything I've just said online. But the silver's definitely quenching. It's problematic. Quenching ingots is problematic. Like I say, I was taught to quench solder jobs, and I did for years, and it didn't manifest in any issues. But then we weren't, you're not generally, apart from ring sizing, you know, there may have been some. You might roll. The only time you're going to roll out a ring is if you're using a gem ring stretcher, really, and you're not rolling it out that much or in its entirety. But yeah, if you quench, which we were doing for a period, if you quench silver ingots, then roll them out, you end up with the porosity in hand poured ingots. Obviously, takes on board the liquid. It then expands inside the liquid, causing blistering, which results in cracking, and you wring out the water in the thing. So silver, I don't think needs it. Gold, I never had a problem. I haven't had any. I don't think I've had any problems quenching it, and by all accounts online, the rapid cooling helps it. But this is another thing. I think people seem to agree that the rapid cooling helps soften it. All metals, generally, or most metals. But then that needs context, because it doesn't. It may well be softer, but if it's cracking because it's taken on board water, it's not a practical quenching it. It's not a practical solution. And that might be. But the point I'm making is, soft's not the only thing we need. We need it soft, but we also need it usable. So, like soft, we need it softable to work with. We don't need it so soft and useless is not an option. So this is what I've come up with. On the gold, I'm putting it on I'm using basically the steel block as a heat sink, and these are cold to the touch, and these get hot when you do this. I've done a few of them, but again, I want to see if this is really an experiment. I'll keep you posted. I wanted to try this on the last batch. So yeah, what I'm doing is rather than, I'm using steel blocks as a heat sink to rapidly cool, and you'll see the colour. It'd be probably better to do this in dimmer lighting. You'll see the colour drain out of these really rapidly. And what I'm doing at the moment is, because from the experience we've got so far, the gold benefits from quenching potentially. I think the main thing they benefit from in terms of annealing these and making them useful is the heating. The cooling. And there's a difference between hardening and tempering, it turns out. So let's get this hot. That I don't really fully understand. And I don't think a lot of the people online seem to fully understand. I'm wondering whether the rapid cooling is basic. So the heating's softening it, reducing stress. And then, I don't know, with some of these alloys, rapid cooling can harden it. It turns out, or temper it. But the one thing this won't make, the one thing the silver can't do, or I don't think it can do, doing it this way, is take on board water. It certainly can't take on board pickle, because we're not putting it in the pickle. But then the other thing with that is, I'm wondering if issues will arise with oxidization. You know, this might end up looking like a Dalmatian dog, because like the pickle obviously removes oxides from the surface. The other thing I've discovered reading stuff on the internet is that the gold benefits from what is sort of termed a heat soak, so getting up to a dull red and holding it there, whereas again the consensus online, but then whether they're talking about fine silver or sterling silver is unclear. Whereas with silver, it's just about doing the whole thing quite rapidly, get it up to temperature, and then remove the heat. You don't need to hold it. That's probably the colour we want. Hopefully, you know, if I stand in the way of the daylight, hopefully you can see that. Is glowing. They call it sort of cherry red. And then what I'm going to do, I'm going to put that on the V block, because then there's two surfaces in contact with the V block. But this is the second time I've attempted this, and the V block starts to get quite hot. That's why I put this below. Almost that's a heat sink for the ingot, and then this bigger block, which is even cooler, bigger block of steel, is almost like a heat sink for the V block. Well, my plan is to do the gold when it's red hot, so to rapidly cool the gold, but maybe let the silver go a little bit, is to cool a little bit before we hit it on the heatsink. The dry quenching is the term I've coined for this. So the gold's going to have rapid cooling, the silver just quicker than air cooling. But yeah, you'll see the, I'll do this with a pair of tweezers, you'll see the colour. If I take the heat off, the colour sort of slowly comes out of it. When you do it this way, the colour just drains out of it, and the steel block obviously gets a little bit toasty. But look at that, just the colour just drains out of that. Do the small silver one. I won't do them all live. This will probably heat up quicker anyway, because the blocks, the reflective block's hot now. I'll tip that other one out onto the. It's not. That was cold to the touch, that V block, and now it's. I mean, it's not hot, but it's no longer cool. Like that has taken the heat out of that. It's probably still warm. It's probably still, you know, too hot to handle. But that's the other thing. When you're quenching it in water, the water basically around it seems to boil and crackle, and it's just a massive. It's a massive change in temperature for the metal, whereas I think this is slightly, because there's some feedback in terms of temperature from the steel, it's not as drastic. Like that's going from, like you drop in the water, you're going from 700 to 700 or 800 degrees centigrade to room temperature, like that. Whereas with this, the temperature's sort of draining rapidly, but I would say also it's like the temperature, the acceleration of that temperature drop as the blocks, so the ingots, I don't know how that pans out. I need a metallurgist to tell me what happens. Maybe I'm hardening it or something. But obviously, as the temperature of the ingot drops, the temperature of the block is rising. So the cooling decelerates. As it gets colder, as the ingot gets colder, the block gets hotter. So it's not like a linear drop in temperature. It's it like be a curve that way, wouldn't it? Well, that's the temperature we need. Let's pour that onto there. So I'll let that go slightly back to yeah, I don't, as I was saying, so I don't think silver benefits in the same way as gold does from quenching. It might even harm it somewhat. So I'm just going to let that go off from red hot, like that is now. Not even warm to the touch. So like that's no longer red hot. but that will drain. It's just not a visible thing. That will drain the temperature out of that. I still think it takes it like that is. I can feel the heat coming off that. That's still too hot to handle, but that will definitely suck the temperature out of it. The block's getting hot, or not? The block's getting warm. But I can still feel the heat on that. I wouldn't want to pick that up right now. So yeah, right, I'm going to do these other two. Same way. And then I'll keep you informed on how my new invention, dry quenching, pans out. The other thing is, once the other issue I've got is once the wire gets long and curly, it's not going to be possible, is it? Like this is going to have its limitations. So you're not dry quenching that on a steel block, are you? Well, actually, with the with silver, the heat conductivity is so great that that will drain. It will still drain it as long as it will still drain it. It just won't drain it evenly. The less pure the alloy, so 9 carat, not so much. That's still hot. I can handle that right now, but that is hot to the touch. This one's too long now to, let's put this one straight on the steel block. That one only just about fits on the V block. Yeah, whenever I see people doing this on social media, when they've freshly poured ingots, silver or gold, boom, straight in, presumably water or pickle. It's just and it's the way I was taught as well. It doesn't work. It softens the metal's softer, but then it causes. It's not that it doesn't work. It causes all sorts of problems in later processes. As soon as you start rolling it, the problems start appearing. But I see everyone doing it, and I was doing it. I did it for the longest time. Yeah, you'd think by now someone said, well, hang on, like this is taking on board water. Something's wrong. Like everyone on TikTok, Instagram, YouTube, They pour an ingot, boom, straight in the water. Maybe we're just special. And ours is taking on board liquid. No one else's is. Or has for the last 5,000 years. It's just us. Right, there we go. Let's let that go off. Going straight on the steel block. So the colour drains out of it slowly anyway. Just that is, it drains out more rapidly. But it's not like if we dunk that in the water, you could handle that immediately. That's still far too hot to handle now. So it's cooling rapidly, just not as rapidly as dunking it, which takes it down to room temperature instantly. So that one is gold. I know it looks black, but that is gold. 9 carat yellow, and that's our silver, looking quite black. That is the one drawback. The bonus of quenching it, especially if you quench it in pickle, it bleaches it and they look good. But it bleaches the silver back to a real white, and it obviously actually the 9 carat looks quite white metallish almost sometimes when you bleach it when you quench it in the pickle. It bleaches it and it looks good. Doing it this way, it doesn't look pretty. Right, I'll let you know how we get on with our new invention, dry quenching. Toodles.